Hey there, Year 11s. I want to go through this example here because it's a common mistake that students can do. So let's have a look here. This is 0.7 to the power of x greater than or equal to 0.3. What I want you to be careful of is here. Most students will then say, once they've learned how to solve for exponentials, so this is x, I want to solve for x. How do I get rid of the 0.7? That's an exponential 0.7. So you would normally then say, do the logarithmic, which is the inverse of exponential, 0.7. So do that to the left, and then you do the same for the right-hand side. True? So for the right-hand side, I'm going to do the same as well. I'm going to do log base 0.7 of the right-hand side. Now we know that through calculation, we can say that log of 0.7 of exponential 0.7 will look something like this. Log of 0.7 of 0.7 to the power of x is greater than or equal to log 0.7 of 0.3. And you naturally say, yep, they're inverses of one another, so these two cancel out. And then you would say x has to be then greater than or equal to whatever log of 0.7 of 0.3 is. True? So if you go to your calculator, I'm just going to show you here. Don't look at the solutions there. If we do this now, what is the log of 0.7 of 0.3? The answer is 3.375. So you would then have said x is greater than or equal to 3755. Okay, 3755. That's already wrong. Okay, and so why is this wrong? And this is where I want you to be careful when you're solving anything to do with decimals. Really think about what the graph looks like. Okay, so I'm going to show you straight off the bat here. We're going to try to sketch this graph. Okay, I'm going to try to sketch it. You don't need to do it beautifully. You just need to kind of visualize what it looks like. You see, when you say 0.7 to the power of x, we know this is a reflection in the y-axis, so it should look something like that. So on my graph right now, I'm going to draw. This is what exponential y equals to 0.7 to the power of x should look like, right? When x is 0, the y-intercept is still 0, 1, okay? But it means that the more you increase the x value, it should keep decreasing, okay? This is from 13C. Now, what is the question asking? They want you to find out when is this graph greater than or equal to 0.3. Now, if this is where 1 is, then 0.3 is about here. True? So if I draw a dotted line just so that we can kind of guess where it is, that's where 0.3 is, right? So at this point right there, when on the x-axis will x equal to, so what x value will give you the y value? So x, where the y value is 0.3. That's essentially what you're trying to figure out, okay? Now, if I solve that on a CAS just so that it makes it much easier for you to understand, if I said solve, whoops, I don't know what's capitals there. Solve for 0.7 to the power of x, and I want that to equal 0.3 comma x, you get 3.375. That's what you were calculating. So here, that tells me when x is 3.375, that's when the graph will be exactly 0.3. Okay, so when x is 3.375, it'll be equal to 0.3. Now the question's asking when will it be greater than or equal to, and our answer says x needs to be bigger than 3.3755. But you can already see that the more you increase, if x is greater than 3.375, the value gets smaller. Can you see that on the graph? That's not true. That can't be true. That means that if for you to get anything greater than 0.3, it has to be above the 0.3 line, right? The only way to get that is if you chose any x values that are less than 3.375. But you can only see that through the graph. See what I mean? So here already, this is the wrong answer if you've kept to it. And the real answer is actually x needs to be less than or equal to 3.3755. So if you did this on your CAS, you wouldn't have the problem. So we went to menu 3.1, and I said solve for 0.7 to the power of x, and we want that to be greater than or equal to 0.3, comma, x, you'll see here, see how it's less than or equal to 3.3755. So if you were to do this by hand, just be careful. Just be careful when you're thinking about the graph. Otherwise, you might make a mistake, okay? So that's a key point just for you to see there. I really think that's key. The better you understand exponentials, the better you understand what the question's asking, you're less likely to make that mistake. Or use a CAS. Just be careful with decimal points when it comes to exponential graphs, okay?